Hello and welcome back to Calculus 1. We are talking about the product and quotient rules. We have separate formula to find these derivatives. When you multiply two functions, you cannot take individual derivatives and then multiply answers. That will give you the wrong thing. So we have a formula that does this. I will start with an example of two functions, let's say x squared times x cubed. And you know that algebra here would command for you to put x to the 5, which would give you 5x to the 4th. And you know that that's the good derivative, right? Note that you're not going to do that if you're not going to get that if you take individual derivatives. It doesn't work that way. So yeah. So we are going to now write this formula in two different forms. One is going to be with f and g, and the other one is u and v. It's the same, it's just using different letters. One is kind of easier to memorize and faster to memorize than the other, but it doesn't matter. So here we go. Oh, forgot to write the derivative. So the derivative of f of x times g of x. So this is the derivative of the product. Is equal to f of x g prime of x plus g of x f prime of x. And this is the formula. Good effort. This is the formula that we would use to calculate the derivative. The other form, which I mentioned, would be the derivative of uv, and that is uv prime plus vu prime, where u is f of x and v is g of x. So this is what we have for our formula. I don't need to amplify that, you can hear it clearly. So there we go. Test. I'm there as well, right? All right. So now we're going to attempt our problem from up here using the product rule. We have the derivative of x squared times x cubed. And the first thing we do is we say, all right, so this is my f and g, or u and v, whatever you want to call it. Right? Let's do f and g. So now what do I have? Copy f. You see, this is f of x, and this is f of x. So it just gets copied. The entire f of x gets copied as is, and then you are taking derivative of g. So copy f of x times derivative of g, that's 3x squared, plus copy g as is, which is x cubed, times the derivative of f, and that's going to be 2x. So now what do I have here? I have f g prime plus g f prime. And all I need to do is to simplify this, and I'm done. Oops. The derivative is equal to And now I have no copying 3x to the fourth plus 2x to the fourth for a total of 5x to the fourth. And we know that's a good answer because we already have 5x to the fourth up there. So all you need to do is to take the derivative. All you need to do as you're taking derivative is to focus which one is f, which one is g, and you will go fg prime plus gf prime, or uv prime plus vu prime. Now, obviously, you might say, we don't really need that rule because why don't I just multiply, right, like we did up there, and there's no need for the rule. Well, sure, that works on this example, but now I'm going to have x cubed times e to the x. Can you multiply these guys using algebra? No. One is a polynomial, the other one is exponential. They're not even compatible, right? So what do you have to do instead? Well, you have to resort to product rule. And that is the way to, I mean, sure, you can go back in time and do the limit. Yeah, good luck with that. I come back in like 3 months. I got it. The class is over. So we are going to copy the first times the derivative of the second plus copy the second derivative of the first. So copy the first, which is f of x, times derivative of e to the x stays unchanged, plus copy the second, which is e to the x, times derivative of the first. Are we ready for some bad news? Yeah, we're always ready for the bad news, right? That's all news is. Bad. Misery, 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 misery. If you ever watch the news. You will have to factor every single one of these when you're done. Factor completely. Because chapter 4 is coming. All right? And in chapter 4, you will be setting this expression to 0 so you can solve the equation. You want to set this equal to 0 and solve the equation? No. You want the factored form, and when you have a factored form, you set each of the factors equal to 0. And that's easy, right? So right now, you are learning two formulas, product and quotient, and then you are learning the fact that you have to simplify your answer as much as possible so that the later chapter 4 work and later in calculus work doesn't suffer from you sitting there, you know, for 25 minutes computing and recomputing things. So we are going to now kick in front of the parentheses x squared e to the x, which are the things that are common for both. And then the leftovers go in parentheses, which is x plus 3. Now this is a side note, right? And we can do it like you know, like in a doctor's office. What's better, this or that, right? To solve. I will erase this. It's just for the purposes of future. When you factor this and you set it equal to 0, and we're going to do this in 4.1, 4.3, and 4.4, and so on. When you do this, now because you have factors, you are allowed to have each one of these separately. So you have x squared equal to 0, e to the x equal to 0, x plus 3 equal to 0, right? None of this is chapter 3 yet. So you have your x equals 0, no solution, and x equals negative 3. Boom. There's solutions, right? So this is what we have as we are taking the derivatives. right? You will have to factor them as much as possible, because you will be setting that equal to 0 to find what you call critical points or inflection points, and then some other stuff with Calc3. So, make sure that you are using the formula for product rule, and also make sure you are factoring your solution. One more for you to practice. ddx of 2 times square root of x times 3x squared. Do we have a brave soul that you'd like to establish? A mathematical dominance over here? What? No, you want to do it, right?
Yeah.
I don't want anything. I want cake.
It's product rule?
It's product rule. You think they fixed this, right? They added a second gear or a second speed. Love it.
This is actually to add, right?
Yes.
Yeah. Alright, I think we got it. Yeah, that's cool. 3 halves.
That's one of the this is a square. So just one is still with
We got it. Yeah.
plus 12x in that. London. Take a selfie with that for social media. They're both the same.
Yeah, I think that.
Well, it's 15x. There we go. That's one here. You terrible people. Oh my God, that's so weak. Why are you so weak? You put some muscle into that. Work hard and look at that. Amazing.
I quit. Great. We have the answer. And the way this was done is pick U and V on the side and found the independent derivatives here. And then plugged everything into the formula. And then algebra, and there it is at the end, right? I'm going to take a little bit different approach, which should give us the same answer, right? And this is the part where you are going to say, oh yeah, right? So let's see if we can get that emotion going. This is x to a half, right? So the whole thing is, you can actually use algebra to make it into a 6, x to the 5 halves. And then you just have 6 times 5 halves times x to the 3 halves, 15, x to the 3 halves, done. Alright? No need for product rule. So when you have to use product rule, you have to use product rule in certain cases, right? When you can't use algebra to simplify the problem to the point where you don't have a product anymore. So this is our problem. But as you can see, what was done in a traditional way of dealing with it, product rule, it works. We still have 15x to the 3 halves. So the rule is, right, anytime when you can cheat, right? Use algebra rather than heavy calculus for no reason. 1/2 exponent from x plus 4/2 exponent there, 1/2 plus 4/2 is 5/2. Formula is n, x to the n minus 1. So n is 5/2, and then 5/2 minus 1 is 3/2. And we got our answer. So that's the product rule. Now we're going to make this a little bit more annoying. Find the second derivative of x squared e to the x. Go. You want self-rule this? It's tricky when you're going to factor here, but it's a good exercise, right? So, try and when you're done with the first derivative, if you simplify it all the way, you're going to get in trouble. So. Yeah. So the key over here is, because you are looking for the second derivative, right? The key is not to simplify all the way after the first derivative. You keep it the way it is
And then you this. There we go. Alright, so this is tricky, right? Let's take a look at this together. And as I said, you don't get to simplify this all the way. Only the last answer you will simplify as much as possible. So we'll start with the first derivative first. So I'll write the function x squared e to the x, and the first derivative f prime. Note that I'm not using Leibniz notation now. I could. I'm just going to use f prime and f double prime. So f prime is a product rule, right? Because we have two distinct functions. I have function f and a function g. So copy the first one, which is x squared, times the derivative of the second one, which is e to the x, plus no copying e to the x, times the derivative of the first, which is 2x. So now we have f prime of x equals to x squared e to the x plus 2x e to the x. Now we clearly see that we can factor x e to the x. And I'm going to do it, but I'm going to erase it. Why I'm going to do it first? So you can actually see that you will have e to the x times x plus 2. How many functions do you have? Now you have 3 functions, right? Now, is there something that's called a triple product rule? Yes, but it's just more formulas and more work and for no reason, right? So 1, 2, 3 functions, it's for a different formula called triple product rule, and they resemble a lot polynomials and stuff like that, but you know, if you're interested, stop by. So I'm not going to simplify this because I don't care about this answer. The question is to find the second derivative. So that's exactly what I'm going to do without simplifying. And look what I have. Basic product rule, basic product rule. I don't have a triple product rule. If you factor, you create a triple product rule. If you leave it alone, you just have 2 basic product rules. I know product rules are annoying and all that stuff, but yeah. So now we start with the first. Copy the first derivative of the second plus copy the second derivative of the first. And then we have a plus, and I'm just going to link that this plus is that plus. There we go. And now I have the second part. So copy the first, that's 2x, times the derivative of the second, well, e to the x is e to the x, plus copy the second, and the derivative of the first is 2. So now, you see that we have 4 terms, and let's just clear it up. So we have x squared e to the x plus, now you see there's a 2x and a 2x, that's a 4x e to the x, and finally plus 2 e to the x. And it is at this point when you see that you can kick e to the x out. And you're left with a polynomial x squared plus 4x plus 2. And that's the answer. So now if you set this one equal to 0, you know it has no solution. And if you set this one equal to 0, you go and you do your thing, right?
when this is equal to 0, you have to solve all of these equations. Some equations are exponential, some are linear, or some are trig, right? So you have a lot of different types of functions, not just e to dx and polynomials. This is applicable to any function that exists. Yes.
Is there another way to write when you have like a d over d to x or d over dx for like this?
For the second, yes, and for all of them. And the insight into how that works is actually great for multiple integrals and all that. So I'm going to explain that in about 28 seconds. Okay, so the question is, how do we deal with the notation if we want to use Leibniz notation? Well, we have to understand first the way the notation works. First, I can say f of x is x squared, and then go to the next line for the derivative and find 2x. Now, this is the line for function, and this is the line for the derivative. Now you can have more derivatives. So what should we do? Well, when you are looking at functions, right, they're going to have the first and the second and so on derivative. We write that as take the derivative of x squared. And that is simply 2x. But now, new and improved, method allows you to pile up the derivatives. See, when you say this is the first derivative, my throat is very scratchy, so I have to make these pauses in talking to reset the voice. It will all be over in 10 weeks, so don't panic. So on the first derivative, we just took the derivative of x squared, we're done. Now, look at your instruction to take the derivative. It looks like this. The top says take the derivative of whatever is in curly brackets. So take the derivative of that in respect to x. Yeah, air conditioning is off. I never thought I'd say those words, but yeah. So, in respect to x. Good.
Okay. So let's go. If this is the instruction, d dx, then we have this to be the two consecutive derivatives. And it should make sense, because if I have, let's say, x squared, and I want to put derivative in front of it as in Leibniz notation, I would have to do this. But then if I want to take the derivative of that, you would still have d dx now over there, right? So this instruction says take one derivative, and that one is closer to the, right? So you'll do that one first. And then this d dx over here will wait for its turn to be applied. So if I want to ask a question for the second derivative, I'll say take the second derivative, and you have these d dx, and they're all squared. If you see a cube or whatever, we have different, or all of it. You can have any power you want, technically, for the derivative. Let's say cube, that's the third derivative. D dx to the fourth derivative. You can have any power you want. You just need to remember that it's the number of instructions that is, this is how many derivatives you have to take. So technically that's that. And I'll write this. I mean, you can put string of 16, but right. So that's the higher order derivatives. So now, if you want to take the second derivative of, let's say, x cubed, you will go and say, all right, I'm taking the first derivative first of x, what did I say, cube? There we go. Perfect. And I'm going to have the derivative of this. So the outer derivative is still there to be taken. The derivative of the inside is going to be, we are working on this part. So that's going to give me 3x squared. And then we're going to have copy 3, and this is, so it's going to be 6x. Right? And you're done. Now, note the cool thing about this notation, right? The cool thing about this notation is that it's linear notation. And if it's a linear notation, you don't have to go and use what I had here, line 1 for function, line 2 for derivative, and so on. So you can have everything in one. So again, pick your notation, do whatever you like. We are not going to have the fourth derivative. As I said, I've seen it only once in application, so, right? We can have any. So you can go and do the 100 derivatives if you want in a chain. It'll just be really annoying to write. So there is that. Those of you that are really interested in derivatives and want to expand your minds, look up what it means to take a half a derivative of something, or 7/2 derivative of something. Yeah, there are derivatives between derivatives that are not part of our course in any. I know you will look it up definitely. If I you don't have to do it now, but I mean you can, sure.
It's possible to do it now.
I know, right? Technology is like, yeah, instant gratification. We can watch this lecture later, right? Because you can't look it up later. Okay, so. Oh, by the way, if you are wondering which websites, anyone gets to write Wikipedia? I love Wikipedia.
And I'm here right now
But-
for fractional calculus.
Yeah, mathworld.org. Right? If you want the answers that are vetted, and mathworld.org is going to be the website, and that is going to have you hop from one concept. It's like a rabbit hole. You know how when you go to YouTube and you see something, and then 7 hours later you forgot to sleep and you forgot to eat, and right? Yeah, Math World. If you are buff for math, could be like that, because in the bottom it's going to give you suggested links, and you just keep following that, and then you don't even know where you started, right? It's like, oh yeah, he suggested something in class. Wasted the whole day. You are welcome, by the way. So the product rule, right, is going to be a function. All of this was a quick question on notation, which took a little bit longer than I anticipated, but yeah, it's within the product rule. Yes?
I just have another question on the notation.
Sure.
You have to write it out like that?
Yes.
Okay.
This is the differential operator. This is the differential operator which says take the derivative. You know license and registration?
Yeah, but I mean below, when you're going that one, you have to write out all the brackets and everything?
Yes, because the notation goes the derivative of, and in brackets is
I meant
the function.
on the other side.
So you have the derivative of something, and then you have the derivative of something. So if you open two brackets, you have to close two brackets, right?
Yeah, but if it's like a relatively simple one like that, would you just accept the answer?
If the relatively simple like this, you should be able to do it mentally without writing anything. Of course, you look at this, you say 6x, right? Let's put sine of x squared there. See how well that works, right? So it's coming up tonight. The next one is trig, right?
Yeah.
Oh, but no, no, it's not tonight. It's next week. So next week we get to see sine squared x or sine x squared or all of this. Please, for next week, if you guys have any issues with the function composition, fix that. This is your last weekend, last chance to fix any issues with function composition. I'm talking YouTube lectures or whatever you need to do for function composition, because next week is the chain rule. And if you don't know chain rule, the calculus is over. And I'm not exaggerating, okay? 90% of derivatives you take are going to be chain rule. And that is the derivative of composite functions, which is function composition, f composed with g or f of g, right? So you have to know that stuff. You have to know function composition, and we will then do the rule. All right, second part of this lecture is on quotient rule, right? The division of two, and it's also going to have a formula which you memorize and then use. So quotient. So what do we have for the quotient rule? We have the derivative of f of x divided by g of x. Now that is going to be, I like to start with the denominator because you just copy denominator squared. And then you take that denominator here times f prime minus f of x g prime of x. Here is the uv prime is vu prime minus uv prime divided by v squared. This is u. So immediately question the derivative, and you can do this on your own, obviously. X squared plus 3 divided by e to the 4x. You have the formulas. Let's see what you get. If you have a question, raise your hand for high five.
Am I even absolutely remotely close? No. Okay. Are we doing anything with this? With natural log to get rid of it?
Not yet.
Okay.
All right, let's take a look at this together. So the entire function on top, right, is going to be u, and denominator is v. Or you can call them fg, same thing. So I will take the function in denominator, e to the 4x, and square it. Then I will put e to the 4x here, times the derivative of the function in the numerator, which is 2x, minus, and then I'm going to take the numerator function, which is x squared plus 3, and then times the derivative of e to the 4x, which we all know is 4e to the 4x. So let me code this v u prime u v prime over v squared. I hope we can all see the formula now and the corresponding factors from the derivative. Are we all green? Perfect. Now we have 2x e to the 4x minus x squared, sorry, 4x squared e to the 4x, and then minus 12 e to the 4x divided by e to the 4x. And yeah, it does look weird, but I'm going to write it like this, because when you have something squared, it's base times itself. So if the base is e to the 4x, then e to the 4x squared is e to the 4x times e to the 4x. Now, the only reason why I did this is experience, but you would eventually stumble on it if you don't know it now. In the numerator, I can factor 2e to the 4x. I can factor that. Then I'm going to write the negative 2x squared, right, because I took 2 out. Then I'll have plus x, because from this term 2 is out, and e to the 4x is out, so x is the only thing that stays. And finally, minus 6 when you take 2e to the x out, to the 4x. And now you have e to the 4x times e to the 4x. Hopefully you see that these two now cancel. And our final answer here now is you can kick minus outside, so negative 2 times 2x squared minus x plus 6 divided by e to the 4x. Now we can factor this more. Oh my God, I don't want to. 2 times 6 is 12. Oh no, we can't. No, we can't, because you have to have minus there. The factors of 12 are 1 and 12, 2 and 6 and 3 and 4. So you can't make negative 1 because they're both positive. Okay, that's it. We're done. X minus 2x minus? Hold on. If you are factoring this as a... Yeah, it's a plus there because they're both positive. You can't get the negative to work in the middle. All right. Good. One more example, and then we are done with this lecture. We take a break, and then when we come back, trig. Woohoo! Huh? I think it's trig. Is it trig? It is? Thank you. All right, so let's take a look at this. What should we put? Something. We're going to do something spicy then. The derivative of... Obviously, we're going to have a quotient. So x squared e to the x divided by x plus 1. There we go. Would anyone like to talk about this problem? Do you have anything to say? I don't like it. That's the first comment. Okay. Anything else? That it's not so self-centered, you know what I mean? Yes. We have to do the product rule. Yes. Do we all see the product rule? Yeah.
That's why it's sticking to it.
So, write this in capital letters, start this problem somehow, and write in capital letters, product rule embedded in quotient rule. Product rule embedded in quotient rule. At one point, and only at one point, as you are doing the quotient rule, you will be taking derivative of the numerator. That's when the product rule kicks in. So the entire problem is a quotient rule. That's the problem. Problem is a quotient rule problem. But at one point, you will do u prime in a formula, or f prime. That's in the second term. When you have that term of f prime and u prime, you have to do the product rule between the two functions on top. Because all others are copying, right? So let's take a look at this problem. And obviously this is going to become much more interesting when we get the chain rule floating about, and then you have the chain rule in the quotient, then quotient in the product, and the product in the chain rule, and the chain rule in the product. To put them all of them, right? And after all that pain and misery, we learned a method that you can take the derivatives mentally without writing anything and give them in a factored form. And you say, why did I sit in a chapter 3 if I could learn this on the first day? But with great power comes great responsibility, so we have to build up. So let's go. Obviously, we'll need a little bit longer line. And we have our denominator of x plus 1 squared. Then we have our x plus 1. And now we are taking the derivative, and that's where the product rule kicks in. So copy the first, x squared, times the derivative of the second, which is e to the x, plus copy the second, e to the x, times the derivative of the first, which is 2x. So what do I have here? I have v u prime. And now I go minus, copy the top, which is x squared e to the x, times the derivative of the bottom, which is 1. Needed a little bit longer line. We have to FOIL, we have to factor, we have to do all of these things, and then we're done. So what do I have? X times, this is going to be x cubed e to the x. Actually, how about I just factor out e to the x in front of the entire problem and not write any e to the x's anymore? Would you all agree that e to the x would factor from here? And e to the x would factor from there? And then these two together, e to the x's will factor there. So that collects all of e to the x's and we don't have them anymore. So, oh, I should have written that this is u v prime. All right, good. So now over v squared. So now, I'm just going to ignore all of e to the x's because I don't need them anymore. This is x cubed plus 2x squared, whatever, plus x squared plus 2x minus x squared.
divided by x plus 1 squared. So these x squares will drop, and everything else is in descending order, so nothing else to do. C to the x cubed plus 2x squared plus 2x divided by x plus 1 squared. Oh, I just noticed there's an x. X e to the x. I can kick x in the numerator. Now we have x squared plus 2x plus 2. X plus 1 squared. So that would be the answer. And why do I want even this x out? It's going to make easier calculation later. Again, later you will say x equals 0, e to the x equals 0, and this big fraction equal to 0, and you solve each one of these, and those are the candidates for min max. We'll see that. Good. Well, that's the product and quotient and the mixture of them. You also see that you can go into the second derivative. You don't want a second derivative on a quotient, right? But maybe it will happen. I don't know. That's that. Take the break, and when we come back, trig. Who's excited? Thank you.